Hey guys, welcome to lesson 4.5, where we're going to continue exploring the idea of similarity and scale factor. So before we move towards making some scale factors and ratios, I do want to review a question of what happens when you dilate a shape by a scale factor of 1. So if you recall, dilating means we're multiplying all the side lengths by whatever that zoom factor is. And if we multiply things by 1, it just gets to be themselves, right? Multiplying by 1 doesn't do anything. And so if I dilate with a zoom factor of 1, then it stays the same. Right, this shape stays the same. All right, so with these shapes, we're going to go ahead and make some ratios and verify that they are indeed equal, because when you have similar shapes, you have to make sure all the ratios between all the matching sides are equal. If they are not, then you do not have similar figures. All right, so here we are going to do two different kinds. One is going to be with the bigger number on top, and then the next is going to be with the smaller number on top. So here, they already made the ratios for us, right? We have 24 over 8, and they also gave us 18 over 6. So when we actually do that division, 24 divided by 8, we get 3. And when we do 18 divided by 6, we also get 3. So what we just did was we verified that the ratios are indeed equal, okay? For this one, we'll do it the other way around. We'll say, okay, instead of putting the big number on the top, we'll put the small number on top, so 8 over 24, and then the other one is 6 over 18. Now for these are unsimplified ratios. If we want to simplify them, we have to go back on our fraction rules and think about what we can divide both the top and bottom by in order to get a more simplified version. And you want to think of the biggest number you can possibly divide by. Like here, we know that both of these can be divided by 2. Both of them can be divided by 4. But the absolute biggest number you can divide both of them by is actually 8. Okay, so if we actually do that division, you get 1 over 3, and that is going to be your simplified ratio. All right, and let's do the same here. You're trying to figure out, again, what can we divide both the top and bottom by? You can divide by 2, you can divide by 3, but really the biggest one we can divide by is 6. Now, you won't always run into a situation where you can just divide by whatever number's on the top, but in this case we can, and it's pretty handy. So if we do 6 divided by 6, we get 1, 18 divided by 6, we get 3, and so sure enough, 1/3 equals 1/3, so they are equal. All right, so now we're going to use this idea to solve for a missing side. One of the lengths has been changed, right? This 8, 6 stayed the same, but now instead of having a 24 height, we have a 20 height, and we want to figure out what this bottom is if these two shapes are going to be similar. So we know that the 8 and the 20 go together because they're the same part of the shape. So we can set up that ratio as 20 over 8. And then the other ratio is going to be involving this pair. We can say equals x over 6. Now notice how I maintained consistency. Because in my first ratio I put the bigger number on the top, or like the number from the bigger shape on top, I have to continue that pattern when I make the second ratio, which means I had to put this x over the 6, okay, and I didn't put the 6 over the x. Once you get to that point, we're going to go ahead and cross multiply. We did learn how to do this some lessons ago, and this is the reason we learned that. Okay, it's particularly so that we could do this skill. So when we cross multiply, we multiply the diagonals. 20 times 6 equals 8 times x. 20 times 6 is 120. 8x doesn't change. And now we want to get x by itself. So we'll divide both sides by 8. And we get a final answer of 15. Okay, because 120 divided by 8 is 15. All right, so the next thing we're going to do is look at these pairs of triangles and see if they are similar or not. Now remember, in order for two shapes to be similar, all the matching side ratios have to be equal. So we're going to create those ratios and see whether or not they're equal. A trick for when you're matching sides is that the biggest side of one shape will always match with the biggest side on the other. So the 50 here is the biggest number. The 39 is the biggest number on this triangle. So those are going to go together when we make ratios. All right, so the smallest number will also match. So 25 is the smallest here and 20 is the smallest here. That leaves us with the 36 and the 28. They have no choice but to be together because that's the only pair left. All right, so now let's go ahead and set up our ratios. I personally like to put the bigger one on top. It's up to you what you would prefer, but whichever way you prefer to do it, make sure you stay consistent. So 50 divided by 39 is going to be one ratio. 25 over 20 is going to be my next ratio. And then 36 over 28 is the last one. So now what we're going to do is go ahead and divide each of those in your calculator. And you'll find that 50 over 39 equals 1.282. 25 over 20 equals 1.25. And 36 over 28 equals 1.286 if we round. Okay, so you realize that all of these are really, really close, but because they're not equal, we do not have similar triangles. They needed to all be the exact same number in order for there to be similarity. So they are not similar. All right, so let's try the next one and see if these are similar. We'll start with the same first step, which is to match our sides. 9 is the biggest side here, and 27 is the biggest side here, so they go together. And we'll set up that ratio. Again, I personally like to put the biggest number on top, so I'm going to do 27 over 9. It just makes division prettier. And 27 over 9 equals 3. Okay. The 15 and the 5 must go together because 15 is the smallest on this triangle and 5 is the smallest on that triangle. So I'll set up my next ratio. 15 divided by 5 is also 3. All right, last ratio. The 6 must go with the 18 because there are no other sides left. And so I'll do 18 divided by 6. Now 18 divided by 6 is also 3. So now that we see that all three pairs of ratios are equal to 3, they're all the same, so we are similar. Okay. So now we're going to continue doing a little bit of practice finding some missing sides. So the first thing you want to do is match the corresponding pieces. So like this left side is going to match with this left side. This right side is going to match with this right side. And this bottom, the base, is going to match with the base on this shape. All right, so now you'll notice that we're actually missing 2 pieces here. So this is actually 2 problems kind of mixed into one. For the first one, we can try to find x first, okay? We know that we need to find x, and so we'll set up that ratio first. X over 11. And you could have done 11 over x. It's really up to you, but like I said, I like to do the bigger number, or like the bigger shape on top. So I've done x over 11. Now, the other ratio that you have to use is going to have to be this 24 and 8, because if you try to use the red one, there's another missing number in there, so that's not going to help you if you're missing 2 pieces, right? You're only allowed to miss 1. So the next ratio we're going to do is 24 over 8, because this will help us solve for our missing side. All right, and we'll just do cross multiplication to solve this. All right, so we'll multiply our diagonals again. So we know that it's going to be 24 times 11 equals 8 times x. Now 24 times 11 is going to equal 264. And then we divide both sides by 8 to get a final answer of 33. So our missing side for x is going to be 33. It's kind of a bad circle. All right, so we found one of them, but we still have to find another one. Now the other one involves these red side lengths here, so let's set up that ratio. We know that it would be 18 over y for the one that has the missing piece. And then the other one we want to use, if you wanted, you could use the green ratio now that you have the missing value, but I'd rather just use the ones that we already had. So I use 24 over 8 again. And as usual, you're going to just cross multiply. Okay, we have 18 times 8 from one diagonal, and the other diagonal is going to be 24 times y, which is just 24y. All right, 18 times 8 is actually 144, so we have 144 equals 24y. And as our last step, we'll go ahead and divide both sides by 24, and that is going to give us a y value of 6. 144 divided by 24 is 6. All right. Got two more practice problems here. So same exact process. Go ahead and match the missing sides, or corresponding sides, I should say. Now I'll go ahead and match this longer side with the longer side, and I'll match the shorter one with the shorter one. So let's set up our ratios. We can go ahead and just call this x because that's the one we don't know. If you used a question mark, I wouldn't care, but I'm just comfortable with x's. So we know that we have an x over 9 equals, the other ratio will be 10 over 5. Like I said, and I'm going to say this a million times probably, you could have done 9 over x and 5 over 10. It's just important that whichever shape you choose for the top, you maintain that for both ratios. All right, we're ready to cross multiply. So we say that 5 times x equals 9 times 10. That's just going to be 90. So then we can divide both sides by 5 to get x finally by itself. And when you do 90 divided by 5, you get a final answer of 18. All right, one last problem. Same exact process. So we're going to match our two longer sides and our two shorter sides. And we can go ahead and start setting up our ratios. We know we'll call this one x, just like we did the last time. So we can say x over 18 equals, my second ratio is going to be 45 over 10. Notice how I stayed consistent. Okay, time to cross multiply. That one's kind of ugly. There we go. All right, 10 times x, so 10x equals 45 times 18. That tells us that 10x is equal to 810, once you put that in your calculator. And our final step will be to divide both sides by 10 so that we can get x by itself. So our answer is going to be 810 divided by 10, which is 81. All right, and that is all for today.